Welcome. In our last video, we introduced aggregate operations. And with that discussion, we talked about the 5 primary aggregate functions: average, sum, min, max, and count. We made the point that an aggregate function operates on a group of rows. In this lecture, we'll conclude our examination of aggregate functions by explaining the group concept in much more detail. In particular, we'll introduce the group by clause that shows us how we can control the groups that are being formed and allow aggregate functions to be applied against more than one group in a single query. We'll also expand on that, providing kind of a predicate or filter condition that applies to groups. And this will be accomplished by discussing the having clause. Although the first part of the lecture was very interesting, quite exciting, we did work with groups, but we did not really define what is a group. Let's take a look at this idea a little more closely. When we omit a where clause, and the query includes an aggregate function, the entire table defines the group. All of the rows in the table will contribute their value to the aggregate function. When we include a where clause, this defines a subset of rows in the table, and that subset then constitutes the group of rows to which the aggregate function will be applied. Let me pose a follow-up question. How can we apply an aggregate function to multiple groups without running different queries? That is, how can we do this all in one query? For example, consider that we wanted to compute the average lab fee of courses sponsored by the computer science department, and also the average lab fee for courses sponsored by philosophy and theology and all of the other departments. It should be apparent that if we have more than 2 or 3 departments, it's not very practical to maintain a separate query for each such department. So what we wish to take a look at here is how we can form the group within a single query and then have the aggregate function applied to each group that is formed. To accomplish this, we'll introduce a new operation or new clause within SQL called the group by clause. With this clause, we can specify one or more columns that characterize the group, and the SQL processing environment will form different groups based upon the columns that we identify. So when a group by clause is included in the query, all the selected rows are grouped by a common value within the column that we indicate. This process will be performed automatically simply by using the group by clause, so there will be no need to specify or identify the actual values that should be present in each group that is to be formed. The aggregate function is then applied to each group formed by this process. So let's consider 3 independent queries and the objective of what we're trying to achieve by consolidating these queries into a single request to the system. Instead of using a where clause to test the condition of the C department column, we request that the system examine all of the rows in the table and take those rows that have the same value in the C department column and put them into a group. And to do this for each such value that the system discovers. This example extends our initial introduction of the group by clause. It takes advantage of the fact that whatever column is present in the group by clause can also be included in our select list. Displaying the department name together with the average lab fee for the department, is much more meaningful. In general, any column appearing in the group by clause or an aggregate function that has been applied to the groups can appear in the select column list. The where clause can be used to include or exclude certain rows from consideration prior to the formation of groups. We've made that point already in our first video. Because a group by clause causes multiple groups to be produced, one for each group formed, there may be a need to control the display order of the result. What this means is we can also include an order by clause in our query. In terms of the syntax, recall that the order by is always the last clause. Group by will come after our where clause and before the order by. Let's consider a query that is interested in processing only 3-credit courses. We'll identify such courses by using the where clause. Then we can do the grouping by department. We can apply the average function to the lab fee, and then in the order by, we can specify that we want the results ordered by the derived value, the computed value of the average lab fee. Let's make a minor modification to this query by removing the where clause. Then we'll run the query, compare the result of the modified query with the original query. If we examine the output of the original query and the output of the modified query, what conclusion can be drawn regarding the where clause in a query that involves grouping and aggregate functions? Clearly, the values for the theology department and the philosophy department have changed. The reason is that each of these departments sponsors a 6-credit course, and that course was included in the computation of the average lab fee for the department. Getting back to my original question, what this tells us about the where clause is that the where clause is evaluated before the groups are formed and before the aggregate function has been evaluated. The syntax of a select statement that uses the group by clause is not really difficult. However, it is important to understand details of the semantics of a query and how the system responds to any query request. For this reason, I want to examine a couple special situations that relate more to the semantics than to the syntax of a complex query involving group by. Let's consider that sometimes a particular group may consist of only a single row. The system will still form the group based upon the value that appears within the grouping column. And this group is formed even if there's only one row or one member within the group. In the current query, we are grouping by lab fees. There are some rows in the course table that have unique lab fees. Such rows will result in the formation of a single member group. This means that any additional information returned about the group, such as some credit, will actually be disclosing information about the individual row that constitutes the group. Also note that due to the sequence in which the operations are performed, the selection criteria that you specify in a where clause could eliminate a potential group prior to the group formation process. In this current query, the where clause eliminates 3-credit courses from consideration. Because the computer science department sponsors only 3-credit courses, there will be no group for computer science. In our previous example, there was no CIS group. This group was never formed. In the current example, there will be one group for each department that sponsors courses. A question that arises is, how could we produce a query result that includes only some of the groups that are formed? For example, suppose we wish to identify only those departments with an average lab fee that is greater than 100. Using clauses and techniques that have been seen previously, we might be inclined to try the where clause. However, the where clause is not the solution here. The issue relates to timing that I've been stressing. The where clause cannot evaluate an aggregate function because the groups have not been formed at that time. The aggregate has not been computed at the time that the where clause is assessed. Thus, we need a different mechanism for this purpose. That mechanism takes the form of a different clause called have. We had indicated that the where clause is not the solution to this problem, but we need the having clause. The having clause can be used to preserve groups within the query result. So, what exactly is the difference between the where clause and the having clause? The where clause is applied to individual rows. The having clause is applied to groups. There's a timing difference. The where clause is evaluated prior to the point in time at which the groups are brought into existence, and the having clause necessarily must be applied after group formation. Additionally, it's applied after the aggregate function has been evaluated, determining a characteristic of the groups. Before we look at the having clause in detail, let's consider the clauses that we've described and the order in which they must be coded, as well as the order in which they are evaluated. The syntax of a select statement is summarized here. We start with select, then from, then where, then the group by, followed by the having, and we conclude with the order by. From top to bottom, this reflects the order of the clauses in a select statement. But what is the actual order of evaluation? Although we must code the clauses of a select statement in a precise order, this order does not correspond to the order in which the operations can be thought of as being evaluated. What I'm going to show you now, I refer to as the logical order of SQL operations. When we code a select statement that includes all of the clauses I've identified, the where clause can be thought of as the starting point for evaluating the statement. The where clause identifies a set of rows to be retrieved from the table, but these rows are not necessarily passed back immediately to the requester. If we have a group by clause, these rows are logically reordered and groups are formed. The aggregate functions that we specify can then be applied to the groups that have been established. Assuming that we may want to include only some of these groups in the final result, the having clause kicks in. This expresses a condition that a group must satisfy in order to be passed on to the next stage of processing. We've discussed renaming of columns. The next point on my timeline explains where we can think of as the renaming taking place. The reason this is significant is we can use the new name assigned to a column in an order by clause, because the order by operation follows the renaming. This new name cannot appear in any of the clauses that precede the renaming step in my timeline, and this is because the name has not yet been assigned. The having clause can only be present if the SQL statement contains a group by clause, and it must immediately follow the group by clause in terms of the syntax. The group by clause offers the potential for more than one group. Thus, the requirement of group by in order to use a having seems logical. In our current query, we're grouping by C department, and for each department, we'll be generating a group that reflects the average lab fee of courses offered by that department. And the having clause will actually eliminate one of the three groups that will be formed. Remember, one of our departments has an average lab fee that is only $87.50. Therefore, that group will not satisfy the having clause and will not appear in our result. A select statement that includes aggregate functions will often contain both a where clause to filter rows prior to group formation and a having clause to filter groups that have been created. In this query, we're extending our notion of grouping by department and computing the average lab fee. Prior to forming the groups, we are saying we don't want the theology courses represented. The groups then get formed, and we'll have a group for philosophy and a group for computer science. The group for philosophy will be eliminated from the results set due to the having clause. Its average lab fee will not be greater than 100. Thus, it's important to understand the logical sequence of the operations SQL follows in response to understanding a statement such as this. Like a where clause, a having clause is not limited to a simple condition, but can have complex conditions connected by Boolean operators. Each condition will relate to some group property. So here we are again grouping by department and computing the average lab fee. Within the having clause, we then determine of the groups that are formed, which ones will be passed on to the final result. The group must satisfy two conditions to make its way to the final result. The group must have an average lab fee that is greater than 100 and also have fewer than 6 members in the group. That means fewer than 6 courses will be sponsored by the department. Although the computer science department has an average lab fee greater than 100, it doesn't satisfy the second part of the having clause. It actually has 6 courses that it sponsors, hence 6 members in the group of CIS courses. Multi-level grouping is also possible, where we could specify, for example, a primary group and a subgroup. In the current example, all courses are grouped first by department. So we'll have all of the CIS courses together, all of the philosophy courses together, all of the theology courses together. Then a second level of grouping is applied within these department groups. This level of grouping is based upon credit. So for CIS, we won't see any difference. But for philosophy and theology, which each sponsor 3 credit and 6 credit courses, there will be 2 subgroups. Once these groups have been formed, then the aggregate functions will be applied. So the aggregate functions are considered then to apply at that lowest level of grouping. That is, it applies to the subgroups. When we have multi-level grouping, we can also employ the having clause to filter out groups that are not of interest to us, or, to put it another way, include those groups which specifically are of interest to us. Again, once the groups have been defined at the lowest level, at the subgroup level, that's the level at which the having applies. So it is possible to have 2 groups for one department that has multiple credit values, and for another department that has multiple credit values, there may be only 1 group because the having clause could eliminate one of those subgroups. With this video, we've concluded our lecture on the topic of aggregate operations. We saw that aggregate operations extend beyond simple aggregate functions, but it entails also addressing the issue of grouping rows, because these aggregate functions operate on groups of rows, so we discussed the concept of the group by clause. Furthermore, we learned that groups are created and can be filtered using what's called the halving clause. So the halving clause allows us to introduce simple or complex conditions that apply to groups that have been created to determine which groups are included or excluded in the final query result. Along the way in our discussion, we talked about the logical order of operations, and I introduced the concept of the timeline to explain how the various operations that take place within a complex SQL statement can be thought of as actually occurring. Whether they occur in the exact sequence I described is not relevant to getting an appreciation of how things work. If you're going to be looking at query optimization, then it's important to understand the exact order in which operations occur. But our objective is to ensure that you write accurate or logically correct SQL queries. In our next lecture, we'll be discussing the concept of the null value as it applies within relational databases. This value can have some strange effects on SQL statements if you're not aware of the presence of this value within your database tables. So I hope that gets you excited about what lies ahead, and you're anxiously awaiting our next lecture. I'll see you soon.